Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to improve our geometry skill. Today is our day number 10. And for those of you who have been watching my geometry videos on day 1 through 9, you know that I explained before that my plan was to cover some basic concepts of geometry in the first few days. Turns out it turns out to be 10 days. Today is it's going to be my last day to explain basic concepts of geometry in the first few days, 1 through 10. And then starting from tomorrow, we're going to start solving geometry problems. And again, in the beginning, the problems are going to be easier on a certain concept, and then as we go along, they're going to get more and more little bit difficult. So today we're going to talk about the concept of slope. Concept of slope. Question is, what does slope measure? I mean, most people know how to calculate slope, just like I'm going to digress here for a second. I want you to learn this word which I've covered many times before. The word is comparable. This word is not to be pronounced comparable, which sometimes people have a tendency of doing. It is not to be pronounced comparable. There is no such word. It's to be pronounced comparable. Watch the video on day number 2. Just type in Keshwani Prep -vocab -day 2 and you will learn this word comparable. The comparable concept, when we're talking about the slope, the comparable concept that comes to my mind is the concept of pi. Now most people, if you ask them what is pi, they will immediately tell you pi equals 3.14. Immediately will tell you 3 is equals 3.14 because they do not understand the concept. Most people know what pi equals to, but if you ask them what is it exactly, they cannot articulate it, they cannot put it in words, they cannot express it. The same thing is going on here. Most people do know how to calculate slope. It's a very simple process. The question, my question here is, what does it measure? What does it represent? What is the concept behind it? Slope measures steepness of a line. It tells you how steep a line is. It tells you how steep a line is. That's what it is. The greater the slope, the steeper the line. Now when I say the greater the slope, the steeper the line, I'm talking about the value of the slope in the absolute sense of the word. For example, I'm going to draw you two lines here. Let's call it line 1 and line 2. Line 2 is steeper. It's going to have a bigger slope. I'm going to now draw 2 more lines. Watch what happens. I'm going to draw 2 more lines. A line going something like this. Line 3 is even steeper than line 2. The only difference is that line 3 has a negative slope, and we'll talk about the concept of positive slope and a negative slope in about a minute, but it has even bigger slope. It has bigger slope only if you ignore the negative sign. So it has some value here, whatever the slope is, it's going to have a negative in front of it. Negative simply tells you that the x and y move in the opposite directions. As I said, we'll talk about that in a second. But line 3 actually has even bigger slope. If you ignore the negative sign, if you just look at the absolute number. For example here, the line 3 might have a slope of -5, and this may L2 have a slope of -4, and this may have a slope of 3, let's say, for example. So line 3, if you look at just by number itself, -5 of course is the smallest one, but I'm talking about taking the absolute value. As you can see, it's very steep. So that's what it is. It tells you how steep a line is. It tells you how steep a line is. Let's carry on then. The greater the slope, the steeper the line. What does it mean for a slope to be positive and negative? Well, let's talk about the concept of positive slope. positive slope simply means that x and y are related in such a way that if x goes up, y goes up. And if x goes down, then y goes down. In other words, x and y move in the same directions. Let me show you an example of x and y moving in the same directions, which we already saw. Let's say we start out with the points such as this one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Let's say we start out with some points like 2, 1. When x is 2, y is, let's make it 1, 2. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 6. There's your line. There's your line. Now, here as you can see, when x was 1, y was 1. When x was 2, let's give them names here. X and y, let's give them name here. Point A was 1, x is 1, y is 2. X is 1, y is 2. That was our point A. When we move from point A to point B, here, x equals 2, and now y equals 4. What we notice is not the fact that the y is equals 4. What we have to pay attention here is that when x went up, so did y. Point B. Point C, when x is 3, when x was 3, y equals 6. Now what if we had gone from point A to point D? If x is 1, y is 2. What if x goes from 1 to 0? 1 to 0. Let's call it point D. So if x were to go from 1 to 0, x is going down, what happens to the value of y? Y also goes down, it goes from 2 to 0. What happens if x becomes negative 1? Let's say point E. If you move from point D to point E, negative 1, y turns out is negative 2. Point E. As you can see, when x goes down, point E, y is negative 1. It went from 0 to negative 1. Since x went down, so did y. Y went from 0 to negative 2. Such a relationship is called a positively sloped line. Positively sloped line simply means that when the value of x goes up, y goes up. When the value of x goes down, so does y. They move in the same directions. Now let's take a look at an example of a negative slope. I'm going to erase all of these things so that it doesn't get too crowded. Let's talk about a negative slope. Let's talk about a negative slope. Negative slope simply means that if x goes up, y goes down. And if x goes down, y goes up. They move, in other words, x and y move in the opposite directions. And we'll take a look at an example of that now. So in the case of opposite directions, we start out with certain value here, a certain point on the line. Let's say x is 1. X is 1 and y is 2. Point A. X and y. X is 1 and y is 2. Now let's say x goes up to 2. As a result of x going up to 2, we would expect the y to go up. Instead of y going up, the y goes from 2 to 0. So we are here now. X goes from 1 to 2, y actually drops from 2 to 0. Let's call it point B. What happens if x goes down one more time? If x goes up one more time from 2 to 3, 2 to 3, 1, 2, 3. As it goes down to 3, the y goes down to 2. rather negative 2. As you can clearly see, x goes up from 1 to 2 to 3, x goes up, y goes down from 2 to 0 to negative 2. We could have started our journey from C and shown the other way around. If we start our journey from C, then you can see that if x is 3, y is negative 2. But when x decreases from 3 to 2, when x decreases, y actually increases from negative 2 to 0. And then when x decreases even further from 2 to 1, y goes even more from 0 to 2. As you can see, they are moving in the opposite directions. Or we can look at one more point. We were at point A here. Let's go from point A to point D. At point A, x equals 1. What happens if x goes from 1 to 0? If x were to go from 1 to 0, turns out y becomes 4. Point D. Y becomes 4. And we have a line here. We have our line here, nice line. And you can clearly see that there is a negative slope line. It has a negative slant. See? Right here. Here is your x-axis, here is your y-axis. Here is my positively sloped line, which simply means that if I start with the value of x here, that x goes up from here to here, y goes up, it goes up here. When x goes to 0, y goes up. When x goes to 1, y goes even more. If x goes to 2, y goes even more. If x goes to 3, y goes even more. It's a positively sloped line. On the other hand, we can have a negatively sloped line where they will be related in the opposite directions. So here our x, when x is whatever this value is, y is 0. When we decrease the value of x, y goes up. When x becomes 0, y goes even more. When x becomes negative, y goes even more. As you can see, they are related in the negative way. They move in the opposite directions. When the value of x goes up, y goes down. And when the value of y goes up, x goes down. Do you understand? And that's all there is. That's all there is. Just because the numbers are going in the negative quadrant doesn't mean the line is negatively sloped. You have to look at the slant of the line. Alright? What else can we talk about? Let me just look at my notes here as to what else I want to talk about. So again, negatively sloped means that if x goes up, y goes down, and if x goes down, y goes up. In other words, x and y move in the opposite directions. How do we measure slope? How do we measure slope? I need the room, so I'm going to erase most of the stuff here. How do we measure slope? Well, slope tells us how fast y is changing when x changes by certain units. By x changes by certain units. So if you want to measure the slope would be simply you look at how fast the y is changing for a given value, for a given change in x. Slope tells us how fast y is changing for one given unit of x. There you go. Change in x over change in y over change in x, which typically a lot of the textbooks refer to change in y as the rise, because that tells you how fast the thing is rising. If I start from here, x is 1, let's say y is 1. When x becomes 2, y is 5. Well, that's rising very fast. This line is rising very fast. Let me do a proper job instead of doing it in a sloppy way. When x is 1, y is 1. So that's my starting point. That's our starting point. When x is 2, let's say y is 2, 3, 4, 5. Y is 2. Well, that's a very steep line. That's a very steep line. This line tells us that for every 1 unit change in x, there is a 4 units change in y. Here, let's make a note of it here. On this line, as you can see, if we went from this point right here where x was 1 to x was 2, here, as you can see, for every 1 unit change in x, for every 1 unit change in x, y goes up by 4 units. Now, this part about going up business is actually not accurate. I should change the word from up to y goes up by, so I move the up a little bit out so I can make the change so you can see the editing. That is true, but a proper way, a better way would be to say that for every one unit change in x, y changes by 4 units. Why changes? Why do I raise the goes up business? Because it applies also equally well to when it goes down. For every 1 unit change in x, y changes by 4 units. In other words, if x goes up by 1 unit, y will go up by 1 unit. If x goes down by 1 unit, y will go down by 1 unit. Do you understand? Now, had it been instead of 4 here, so here the slope in this particular line, the slope equals 4. What would have meant if the slope instead of being 4 had it been -4? A slope of -4 still says the same thing. Slope of -4, first of all, let's first understand the 4 part. Then we'll talk about the negative part. 4 part tells us exactly the same as this part. This 4 part here. The 4 part tells us that for every 1 unit change in x, y will change by 4 units. And then it tells you in what directions. Negative tells us that x and y, negative sign tells us that x and y move, I don't know if you can read that low, in the opposite directions. In the opposite directions. I don't know if you can actually read that low, but that's what it is. So if the slope of something happens to be -13, one more time I'm going to repeat it. If slope happens to be -13, the 13 part tells us how fast y changes for every 1 unit change in x. So 13 tells us that if x changes by 1 unit, y will change by 13 units. In what directions? In the same direction or in the opposite directions? Well, for that we have to see the sign. If it's a positive sign, then they move in the same directions. If it's a negative sign, that tells us that they move in the opposite directions. So here, the negative tells us that for every 1 unit, for every time x goes up by 1 unit, y will go down rather, sorry. That's the negative part here. They move in the opposite directions. So here it tells us that every time x goes up by 1 unit, y will go down by 13 unit. And the vice versa is also true. It also tells us that if x were to go down by 1 unit, y will in fact go up by 13 unit. So 13 part tells us how fast y is changing when x changes by certain units. So here's this is typically referred to, change in y is typically referred to as a rise, and the third last part is referred to as a change, as a run. And how do we measure it? You simply look at how much did the y changed from one point to the other point, y2 minus y1, whatever the coordinates are, and how much did the x change. That's all. And this part, y2 minus y1, is exact same as y1 minus y2. It doesn't matter which point you treat as an initial point and which point you treat as a final point. You're going to get the same answer. And I'm going to show you that last part before we wrap the video. I'm going to show you here that the answer is going to be the same. It doesn't matter whether you start with x2 and y2 or whether you start with x1 and y1. It doesn't matter which point you call the initial point and which point you call the final point. It's not going to change the slope. I'm going to show you the last part. Or perhaps I should leave it here. Just take my word for it right now. I'm going to show you in the next video that it doesn't matter. See, for example, here. Let's take a look here. Or better yet, I can just give you the example. Let's say we go from right here, from 1, 1 to 2, 5. x1, y1 equals 1, 1 right, in this example, 1, 1, oh sorry, it was 1, it was 2, 1, wasn't it? This 2, 1, let's call it point A. Oh, it was 1, 1, sorry. From 1, 1, right here, point A, I don't know if you can actually see it, to point B, which is 2, 5. X2, Y2 is 2, 5. Let's see what happens. If we were to treat, let's call them point B, point A and point B. If we were to treat point B as our final point and point A as our initial point, then our journey starts with point A and ends at point B, in which case point B is the final point. So we will go here, coordinates of this one are 2, 5, 2, 5, and coordinates of this one are 1, 1. Let me erase this so it doesn't become so crowded here. Coordinates of this one are 1, 1. So if we were to treat point B as our final point and point A as our initial point, then we'll simply go, it will be the final point where you arrived at minus the initial point, so it will be 2 minus 1 for X and 5 minus 1 for Y. So it will be 5 minus 1 over 2 minus 1. And 5 minus 1 is 4 and 2 minus 1 is 1, so 1 over 4 is just 4. Which would also be equal to, if you were to treat point B as our initial point and point A as our final point, in which case it will be, the change in Y will be 1 minus 5 over 1 minus 2. So we'll get negative 4 over negative 1. As you can see, negative 4 over negative 1, the negatives cancel out and you still get the 4. Slope does not change. Slope is still 4. It doesn't matter which point you treat as the first point and which point you treat as the final point. So don't freak out about, oh my god, which one is Y2 and which one is Y1, as long as you're consistent. If you're going to call this one Y2 and go Y2 minus Y1, then you have to do X2 minus X1. You have to be consistent. It doesn't matter which one you do which one. Starting tomorrow, we're going to start solving some problems, and we'll do as many as we can. And as we do the problems, you will see that your geometry skill, you will see a marked improvement in it. Alright? I'll see you tomorrow then, okay? Bye.